Dear students, welcome to s.mathguru classes. Now our main discussion is maxima minima of three variables, Lagrange method of undetermined multipliers. We solved some problems. Next we consider the remaining problems. All of these are easy, very interesting. If you are feeling easy with me, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon also. Now let us consider one problem. Show that the stationary value of u equal to x to the power m, y to the power n, z to the power p, where x plus y plus z equal to a is m to the power m, n to the power n, p to the power p, a to the power m plus n plus p, divided by m plus n plus p to the power m plus n plus p. This is our answer. Stationary value is this, and function given this, and phi given this one. Now here what are given? First we have to write what are given. Here u equal to given x to the power m, y to the power n, z to the power p, and phi equal to given x plus y plus z minus a equal to 0. A taking left hand side, we consider phi. So first we consider del u del x. When we differentiate with respect to x, y and z constant, then we get m x to the power, or first we write this y n z to the power p del x x to the power m. This will be y to the power n z to the power p m x to the power m minus 1. This is m x to the power m minus 1, y to the power n, z to the power p. We get this one. Next we find del u del y. Del y, and this is we differentiate this one, x to the power m, y to the power n, z to the power p, and this is y to the power n, z to x to the power m, x to the power m, z to the power p outside because these are constant, and this will be n, y to the power n minus 1. If we differentiate y with respect to y to the power with respect to y, then we get this, and this will be n x to the power m, y to the power n minus 1, z to the power p. We get this one. Next we find del u del z. At the time these two are constant, this will be outside, y to the power n del z, z to the power p. We get this one, and this will be x to the power m, y to the power n, p, z to the power p minus 1. This is p x to the power m, y to the power n, z to the power p minus 1. These are del u del x, del u del y, del u del z. Next our requirement phi del x. Del x, phi means x plus y plus z minus a, and this will be 1 plus 0 plus 0 minus 0. This is 1, del phi del x. Now del phi del y. Del y, x plus y plus z minus a. This is 0 plus 1 plus 0 minus 0. This will be 1. Next del phi del z. This is del z, x plus y plus z minus a. And this will be 0, 0, 1 minus 0. This is 1. We get this one. So by Lagrange equations, we have del u del x plus lambda del phi del x equal to 0. First we get this equation. Next, del u del y lambda del phi del y equal to 0. Del u del z lambda del phi del z equal to 0. These are called Lagrange equation or Lagrange method. And putting the ready-made values, if we putting the ready-made values, first equation we get del u del x we get m to the power m into x to the power m minus 1 y to the power n z to the power p lambda into 1 equal to 0. We get this one. So this is m x to the power m minus 1 y to the power n z to the power p plus lambda, this equal to 0. This is number 1 we consider. And del u del y, this equation we get del u del y is this. Del u del y, this is n x to the power m y to the power n minus 1 z to the power p lambda into 1 equal to 0. Del phi del y. Del phi del y means 1. This equal to 0. Then we get n x to the power m y to the power n minus 1 z to the power p plus lambda equal to 0. This is number 2. And the last one we get p x to the power m y to the power n z to the power p minus 1 plus lambda into 1, this is 0, and this is number 3 we get, number 3. Now we multiplying this equation 1, 2, 3 by this equation multiplying by x, this equation multiplying by y, and this equation multiplying by z. What we get? Now equation number 1 multiplying by x plus equation number 2 multiplying by y and equation number 3 multiplying by z, and adding we get this is m x to the power m minus 1 y to the power n z to the power p, this is z to the power p plus lambda x, and this equation multiplying by y n y x to the power m y to the power n minus 1 z to the power p plus lambda y, and this equation multiplying by z p z x to the power m y to the power n z to the power p minus 1 plus lambda z equal to 0. And here we get m, this first one multiplying by x, then here m into x. This is x power 1, this is minus 1, so this will be x to the power m. 1 and minus 1 cancel, then x to the power m, y to the power n, z to the power p. And this one we write first, n x to the power m, this power 1, 1 cancel, y to the power n, z to the power p. And this we write p x to the power m y to the power n, and this is into z to the power p. This will be z to the power p plus lambda taking common here, these three terms lambda common, we get x plus y plus z, this equal to 0. We get this one, and from this 3 we get x to the power m, y to the power n, z to the power p common. Here we get m plus n plus p, and here lambda into this is a, lambda into a, because we know x plus y plus z equal to a. Better to write this since x plus y plus z equal to a. And this will be x to the power m, y to the power n, z to the power p, m plus n plus p equal to minus lambda a, and lambda equal to, so lambda equal to x to the power m, y to the power n, z to the power p, m plus n plus p divided by a we get. This is the value of lambda. Now we putting this value in equation number 1. What we get? Now 1 implies, if we putting the value of lambda in equation number 1, then 1 implies m x to the power m minus 1 y to the power n z to the power p plus lambda. The value of lambda just we get, this is minus x to the power m, y to the power n, z to the power p, m plus n plus p divided by a, this equal to 0. We get this is 0. Now this implies m x to the power m by x, we can write x to the power m by x, power minus 1 given, minus 1 we can write x to the power m by x, because we know this formula from lower class, a to the power m minus n equal to a to the power m by a to the power n, or a to the power m minus 1 given, then a to the power m by a, or a to the power 1 we can write. Using this formula, m minus 1 given, we write x to the power m by x, and yn z to the power p remains same, and this one x to the power m, y to the power n, z to the power p, m plus n plus p by a, this equal to 0. And from these three terms, we are taking x to the power m, y to the power n, z to the power p common, we get m by x minus m plus n plus p by a, this equal to 0. This is we get 0. So this m by x minus m plus n plus p by a, this equal to 0, because this cannot be 0. If it is 0, then whole function will be 0. Product of two functions 0, factor of 0 means either this equal to 0 or this equal to 0, but this cannot be 0. And this will be m by x equal to m plus n plus p by a, and this implies x equal to a m by m plus n plus p, this one, this multiplying this side, this one, this x that side. So the value of x we get am by m plus n plus p. When you putting this value is here, we get this one. Again lambda value here, then we get this one. Again putting the value of lambda here and here, we get this one different. From similarly, putting the value of lambda in equation 2 and 3, we get in equation 2 and 3, we get, if we putting the value of lambda here, equation number 2 and 3, when you putting 1, then we get the value of x. Putting in 2, then we get value of y, and putting in 3, then we get value of z. Then we get x equal to an by m plus n plus p. This y equal to, not x equal to, and z equal to, we get a p by m plus n plus p. We get, these are the values of x, y, z. So x equal to am by m plus n plus p, y equal to an plus m plus n plus p, and z equal to ap by m plus n plus p. And putting the values of x, y, z in equation number this u, one equation number. Since u equal to x to the power m, y to the power n, z to the power p, and just we get the values of x, y, z, x, y, z, putting here, ultimately we get our answer. This implies u equal to x. X means am by m plus n plus p to the power m, and the value of y, an by m plus n plus p to the power n, and value of z, ap by m plus n plus p to the power p. We get, these are the values. And if we calculate this one, we get u equal to a to the power m, m to the power m by m plus n plus p to the power m into a to the power n, n to the power n by m plus n plus p to the power n into a to the power p, p to the power p, p to the power p by m plus n plus p to the power p. Just separate this power, we get this one. Now this implies u equal to, we m, n, p, we write together, m to the power, we write m to the power m, n to the power n, p to the power p, and a to the power m, a to the power n, a to the power p. These are together, and these base are same, power will be 8, then this will be m plus n plus p to the power m plus n plus p. Because we know this formula, a to the power m, a to the power n, by index formula, a to the power m plus n. If base are same, then power will be at m plus n. We get the same method, we get this m plus n plus p, m plus n plus p, these are same in multiplication, power will be in addition. This implies u equal to m to the power m, n to the power n, p to the power p, a to the power m plus n plus p by m+n+p to the power m+n+p. This. So this is the value of u. So our requirement show that the stationary value of u is this, and this is our proof. Short. Very nice solution, very easy. So I hope you are all enjoying with me. If you are all enjoying with this type of problem, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.